Hello, geometry students. So today we're going to continue with trig ratios, but we are going to have to actually find a missing side first, either by recognizing the Pythagorean triple or using Pythagorean theorem. Okay, so remember, excuse me, if you remember from the previous lesson, we had SOHCAHTOA. And SOHCAHTOA tells me that sine is opposite to hypotenuse, cosine is adjacent to hypotenuse, and tangent is opposite to adjacent. So for the first example, it says find the value of the sine of d rounded to the nearest hundredth if necessary. So remember, the sine is the ratio of the opposite side to the hypotenuse. So if I find angle D in the picture, here's angle D. So the hypotenuse is this side here, which I'm missing, and the opposite is 9. So it's going to be 9 over something. I got to figure out what the something is. So since I'm missing the hypotenuse, we again need to find that first. So you can either recognize that there's a triple that involves a 9 and a 40, so you could do that. If you do not, you have to use Pythagorean theorem. So the hypotenuse would be my C value, the 40 and the 9 would be my A and my B. So again, according to Pythagorean theorem, we know that A squared plus B squared equals C squared. So we're going to have 9 squared plus 40 squared equals C squared. 9 squared is 81. 40 squared is 1600. If I add that together, we get 1681. And then to find my C, we're going to take the square root of both sides. Now test to see if it's a perfect square first, because if you take the square root of 1681, you actually get 41. So where this came from is one of the Pythagorean triples, remember, is 9, 40, 41. So if you would have recognized that, you could have avoided the Pythagorean theorem. Okay, but again, if you did not recognize it, you're going to work it out here. So my hypotenuse is 41. So if I want the sine of D, I'm going to put 9 over 41. Now notice it doesn't say it once as a decimal. It says we're going to round to the nearest hundredth. So on a calculator, you're going to take 9 divided by 41. If I zoom in a little bit, here you can see my calculator. So it's 0.219512, etc. So since the direction says nearest hundredth, hundredth is the second place after the decimal. Remember, tenths, hundredths. So it's 0.21195, etc. So this is the hundredth spot. We're going to chop it off. So since to the right of it we see a 9, that means the 1 is going to round up to a 2. So my answer would be 0.22. Again, make sure we're following the directions. So again, I'm rounding to the nearest hundredth. Okay, in the second question, it says find the value of the cosine of n, again rounded to the nearest hundredth. So cosine, again, is, if I look at the CAH, cosine is adjacent to hypotenuse. So adjacent to hypotenuse. So if I look at angle N in the picture, my adjacent side is this one, and the hypotenuse is the 50. So it's going to be something over 50. So if this is a Pythagorean triple, you could use that concept to find my missing side here. If you don't recognize it as a triple, then you would have to use Pythagorean theorem. So if we let this side be A, again, if we have A squared plus B squared equals C squared, I'm going to have A squared plus 48 squared equals 50 squared. So 48 squared is 2,304, and 50 squared is 2,500. So if I'm going to continue solving for A, I'm going to subtract 2,304 from both sides. So 2,500 minus 2,304 gives me 196. And then I would go ahead and test to see if it's a perfect square. So the square root of 196 is 14. Again, where this comes from If you use the Pythagorean triple concept, 48 and 50 are both divisible by 2. So you could have said this is 24, 25, and then there is a triple that involves 24 and 25. It is 7. So again, to multiply it by 2 to go backwards to find each side, like 25 times 2 is 50, or 24 times 2 is 48. So this side is 14. So either you use your triples or Pythagorean theorem, it works the same way. So again, cosine is adjacent over hypotenuse. So I'm going to put 14 over 50. And again, we're supposed to find it as a decimal. So again, on my calculator, if I take, 14 divided by 50, you can see my screen here. If I hit enter, it's 0.28 exactly. And this is the tenths, so this would be the hundredths, and I don't have to round anything. So my answer would be 0.28. So again, we're still using our trig ratios, but we have to use Pythagorean theorem or our triples to find the missing sides. Okay, if I look at my next example, it says express the cosine of L as a fraction in simplest terms. So cosine, again, remember, is adjacent over hypotenuse. So if I look at L in my picture, this side here, LM, is the adjacent, and my hypotenuse is the 11. So it's going to be something over 11. Now, again, I got to figure out what the something is. So to do that, we don't have a triple that involves square roots. So you just have to, on these, to actually use Pythagorean theorem. So if I call this side here my A, again, we know A squared, let me zoom out a little bit here, sorry. A squared plus B squared equals C squared. So I'm going to have A squared plus the square root of 56 squared equals 11 squared. Okay, now remember, when we did square roots, when we square a square root, it undoes itself. So when you square the square root of 56, you're just left with 56. And when you square 11, if you need to, use a calculator. 11 squared is 121. So if I'm going to continue here, the next thing I would do is to subtract 56 from both sides. So if I subtract 121 minus 56 is 65. So to find my A value, I'm going to take the square root of both sides. 65 is not a perfect square like it was on the other ones. 65 is not divisible by a perfect square. So it's going to be the square root of 65. Now again, that's the sign I'm missing. I needed to find cosine. So we're going to put the square root of 65 over 11. Now again, notice my directions say to write it as a fraction. Right now I have it as a fraction. This can't be reduced, so this is what I would type in as my answer. Today you're going to be doing delta math, so you would type in the square root of 65 over 11. So again, the first few that you're going to be looking at today, they should be Pythagorean triples, or they should work out nice with Pythagorean theorem, like we saw in the first two. There will be a section where you have to, again, use Pythagorean theorem, and you may end up with radicals, so just be aware of that. Okay, so if I continue with my next example, it says express the cosine of D as a fraction in simplest terms. So again, cosine, I'm doing a lot of cosine problems here, that's okay. Cosine is adjacent to hypotenuse as a ratio. So if I'm focusing on angle D, my adjacent side is this one, and the hypotenuse is 16. So it's going to be something over 16. But to find that something, again, I have to use Pythagorean theorem. So I'm going to do A squared plus B squared equals C squared again. So in this case, my B squared is going to be 15 squared, and my hypotenuse is going to be 16, so 16 squared. And again, if you need a calculator, that is okay. So 15 squared is 225, and then 16 squared is 256. So if I'm going to solve for A, I'm going to subtract 225 from both sides. So A squared is going to equal 31. So my A value is going to be the square root of 31. You cannot reduce that because 31 is a prime number. So again, if I go back to my problem, I want the cosine of d. So cosine is adjacent over hypotenuse. So I'm going to put the square root of 31 over the hypotenuse, which is 16. And notice the directions say to express my answer as a fraction. Since I cannot reduce this, this is my answer, the square root of 31 over 16. Now again, as a reminder, you cannot have a radical in your denominator, which in this problem we did not. We had 16, that's not a radical. And on the previous problem, we had 11, which is not a radical. So if you would get a radical in the denominator, you would have to make that adjustment. Okay, on the last two examples, these are meant to be easier than the previous ones, but what will be important for you is to draw a picture. So in this one, it says triangle KLM. We have a triangle KLM, and the measure of angle M is 90. So draw me a picture of a right triangle. Here's my 90-degree angle, and they said M is 90. So that means M has to go here. So if I'm thinking about how the triangle is named KLM, if one is M, the other two have to be K and L. And it doesn't matter which one's which. So we're going to put K at the top and L over here. You could put it the other direction, and that is fine. Next, we want to label the sides. So if LK is 5, here's LK. So we're going to put a 5 there. If KM is 3, here's KM. We're going to put a 3 there. And ML is 4. So we're going to put a 4 there. So now that we've drawn our picture, we've identified the vertices and labeled the lengths of the three sides, we're going to answer the question. It says, what ratio represents the cosine of angle K? So again, cosine is always adjacent to hypotenuse. So here's K, since I'm focused on angle K here. So adjacent would be this 3, and hypotenuse would be the 5. So I'm just going to put 3 over 5. And it wants it as a ratio. A fraction is a ratio, and it can't be simplified, so it's just 3 over 5. Okay, if we look at the last one, same kind of thing. We got to draw on our picture. So we have triangle XYZ, and angle Z is 90. So if I draw my right triangle here, and here's my right angle, that means this is Z. So if the triangle is identified as triangle XYZ, if Z is here, X and Y have to be the other two vertices. So it doesn't matter which one's which. I'm just going to put X at the top and Y at the bottom. Again, it doesn't matter. So if I label my sides, XZ is 20. So XZ is here. This is 20. If X or YX is 29, here's YX here. I'm going to put 29. And it says ZY is 21. So I'm going to write that here. It says, what is the value of the cosine of X to the nearest hundredth? That means I'm going to have to write it as a decimal. So the cosine, again, in general, is, I feel like we could be doing a lot of the cosine problems, but it's just a trig ratio, adjacent to hypotenuse. So if I focus on X, adjacent is the 20, hypotenuse is the 29. So if I do 20 over 29, again, that's what it is as a ratio, but it wants it as a decimal right into the nearest hundredth. So if I take 20 and divide it by 29 on my calculator, and I zoom in so you can see it, so it looks like it's 0.6896, etc. So the hundredth spot, so let me shift my paper here, sorry. The hundredth spot, so the 6 is the tenths, the 8 is the hundredths. So I'm going to chop it off. I look to the right of it, I see a 9, so that means that 8 is going to round up to a 9. So my answer would be 0.69. Okay, so for today, you have Delta Math. Okay, your problems are going to be similar to these. Okay, sometimes they'll work out nice, sometimes they'll have a radical in it, and sometimes you will have to draw your own picture. Okay, if you have any questions, please let me know. Bye.